Welcome back everyone to this lecture on dealing with categorical data. We're actually going to jump straight to the transformation of the data in the Jupyter Notebook. But before we do that, I want to ask you to please make sure to have watched the section introduction lecture video in full for a detailed discussion on things like dummy variables and one-hot encoding. If by the time you're watching this video, you've already seen a lecture discussing dummy variables, integer encoding, and one-hot encoding, then you're good to go. If you don't know what video I'm talking about, it's highly likely you accidentally skipped the section introduction video. Go ahead and go back and watch it because we're going to discuss the details of a lot of the concepts shown here in this lecture in that section introduction. Alright, let's get started and head to the notebook. Alright, here I am at the notebook, and I've already done a couple of things. I've imported NumPy, Pandas, Matplotlib.pyplot, and Seaborn, and I've also opened the Ames housing feature description text file in reading form and then printed that out in order to see the descriptions for the features. And then what I've also done here is I'm going to be working with the Ames nomissingdata.csv. This is essentially a CSV file that is directly related to the series of lectures we just finished where we removed any missing data. So if you read in this file, you should be able to say df is null.sum and see that all of these are equal to 0. Okay, so for instance, if you said this, you'll get everything as false. Okay, so what we're going to do here is just work with this data frame and see what we have to actually convert from a categorical feature to something like dummy variables. There is one feature, however, that's kind of a little tricky to begin with, and I'm going to scroll down here to show it to you, but it's essentially the MS subclass feature, because technically it is numerical, but you could think of it as categorical. It's not the same as something like overall quality, where there is a clear ordinal relationship between the numbers, 10 being better than 9, 9 being better than 8, etc. While these are technically categories of very excellent, excellent, very good, it's also ordinal enough that I don't need to worry about some sort of conversion here. Keep in mind, overall quality is a number, and these numbers do represent categories, but clearly there's an order to these categories, and I can think of this as being on a linear scale. There's nothing I need to actually change there. However, there are going to be some features that have numbers to them, so they're numeric features, but in fact, they are actually categories. And the main one to consider is MS subclass, which identifies the type of dwelling involved in the sale. And you may think you don't need to do anything with this one because it's already numeric. It's 20, 30, 40, 45. However, what you would need to consider is the fact that this is essentially integer encoding. As we previously discussed, this implies some sort of linear relationship between all of these values. That is to say, something like the value of 40, a one-story with finished attic all ages, is double the value of one-story 1946 and newer all styles. And that definitely may not be the case, especially when you start to consider how many categories there are here. So what we're going to do to quickly fix this, instead of keeping these as numbers, I'm going to convert them to strings. And we'll see why in just a second. But what I'm going to do is say the column for MS subclass, since it's right now integers, we'll say is equal to df MS subclass, and I'm going to apply str, string. So you might think at first you're moving in the wrong direction here, taking something that's numeric and applying it so that it's string. But now that it's string, I can actually then easily create what are known as dummy variables. And the reason we combine it to be a string is because I want to grab all the string values throughout my entire data frame at once. So how does this actually going to work? Let's start with a very simple example. I'm going to say create a series called direction, PD series, and it's just going to be up or down. So we'll say up, up, and then let's go ahead and say down. Very similar to the example that we did earlier in this lecture series. And then we say direction. We can see it's a series that looks like this. I can say PD get dummies, and this is a method of automatically creating the dummy variables. So we pass in direction, and it takes in a single series column, and then what it's going to do, these have to be categories, and then it's going to create, as we previously discussed, a column for each particular category with a one-hot encoding. And as we also discussed previously, this is technically duplicate information, so I should be able to easily drop one of these columns and still retain the same amount of information. And for that, we simply say drop first is equal to true. It doesn't really actually matter which one we drop. And when we run this, we'll now see that we dropped one of the columns, and I retain all the information from this up-down feature in this single column, because I know that if it's not up, by default, it must be down. Okay, so we've already discussed all of this. Main thing to show you here is that we can easily convert a column of string features to dummy variables by saying pd get dummies, pass in the string feature, and then say drop first is equal to true. And what's really nice about pd.getDummies, you can actually pass in a list of series or a list of columns. So how can I grab all the columns to consider? For this, I can use data frame select data types, which is df dot select underscore d types, which is date types, and then we're going to say include equal to, and for the version of Pandas I'm using, I'm simply going to say object in a string. And you run that, and essentially what this does is it looks at the data type for every single column and checks if it's equal to object, which essentially is the way Pandas defines a string. And recall, if I say df info, it's going to report back what it thinks these objects are, whether they're objects, integers, floats, etc. And so for all of these, it's going to check only return the ones where the data type is an object, essentially a string. So that's all I'm interested for converting for dummy variables. And that's what it does when I say data frame select data types include equals object. So now notice these are all strings, which is why I said ms subclass should now be a string so that it's included when I run this command. So technically it looks like a number, but I already know because of what I did up here, apply str, that it is in fact a string. So how do I actually convert this? Well, in this case it's actually quite easy. All I need to do is the following. I'm going to say data frame objects dummies is equal to pd.getDummies. And then what I'm going to do is essentially define up here. Let's go ahead and grab this, copy, and say my object columns, I'm just going to say my object df is equal to df select data types include all object. And here's what's really cool about select data types. I can actually do the opposite. I can say my numeric df is equal to df select data types, and there's an exclude parameter. So if you pass in the same thing to include and exclude, essentially what we do is we break the data frame into two parts. One with all the string objects, and then if I run this, one with all the numeric objects. So I can actually confirm this by saying my numeric data frame, and here we can see all of these are numeric values, either floats or integers, which is pretty much exactly what I want. And the reason I split this up into two parts is I want to transform this into a bunch of dummy variables and then reattach it to the original numeric feature values. So here are my string features, here are my numeric features. We'll only edit the string features and then paste them back in or concatenate them back in with the numeric ones. So now that I split that up into two parts, I can say pd get dummies, and I'm going to pass it to my object data frame. So I'll say my object df, and then I'm also going to say drop first is equal to true. So when I run this, I'm going to get back something that's really large because it's going to create dummies for every single category. So now I have 238 columns. Keep in mind, realistically, I'm not going to create a coefficient for every single one of these columns. Later on, we're going to discover how to use regularization to actually check if any of these features are even important. So that's what's really nice about something like the lasso regression that we learned about. Easily, one of these features is not going to be very useful, so we'll put it to 0. And here we can see now, if you just scroll over to the right, how many columns we have for all these various features. Okay, so that's what's really cool about this. Very easy to do. Now what I need to do is join back these results with my numeric values. To do this, I can simply concatenate them. So I will say my final data frame is equal to pd concat with df, or what do we call this here? df, or my numeric df, excuse me. So I'll say my numeric df with what we just called this result, which is df objects dummies. So we'll concatenate these together. I'm going to do it along axis is equal to 1. And after running this, our final data frame should be something really large. And this is kind of just realistically what you're going to be spending most of your time on, is editing data sets and then creating a bunch of features. So we've done everything from dealing with categorical features to dealing with missing data and then cleaning up our data as well. And it's all now ready to go. So we have done a ton of work here. And keep in mind, we still don't really know if 274 columns are all going to be useful. It's highly unlikely to get an accurate prediction for the house price that we need 274 really strong signal columns. Realistically, we're going to use regularization later on to help us choose important columns. And maybe later on we find out that many of these features aren't even necessary to consider. What we could also do is begin to analyze things like correlation to sale price and see if any particular subcategory is actually really important. Keep in mind, at the end of the day, we still have to consider the human aspect that came with this data set. In particular, something like overall quality. Recall that overall quality is still highly correlated to the sale price. We can confirm this by saying calculate the correlation and then get sale price. And then what we're also going to do is sort it. So we'll say get sale price and then sort the values. So you run that and we still see that the overall quality component is 0.8. Clearly, this is going to be a very strong feature when we're talking about the sale price of a house. What is also nice, I can begin to see kind of new features that were created, this exterior kitchen quality, etc., fireplace, that even if they have really strong negative correlation, that's still actually a strong signal. What we're looking for is something that has a really large absolute value correlation. Now, what's the issue with overall quality? Why is this going to be a problem for us in the future? Realistically, it's a problem because overall quality of a house, at the end of the day, is most likely a measurement created by a human. Some human had to come in, look at the house, and rate it from 1 to 10, which means any future house that comes on the market, you're not just going to be able to plug in all the actual quantitative values. You will, at the end, need someone to give it an overall quality value off of that. We don't actually know, maybe the overall quality was feature engineered based off a bunch of other features, but it's highly likely that it's actually a human qualification, which means any new data is not going to be completely automated away. We will need some human realtor to give it some quality score or score from 1 to 10. It's just another consideration to think about when we're talking about automating processes with machine learning. It's often difficult to completely get rid of the human throughout the entire process. But we have this final data frame ready to go. You can go ahead and feel free to save it, or just use our AIMS final df.csv file for the upcoming project walkthrough. Okay, that's it for cleaning up the data and feature engineering. I hope you found it useful. It's not the most exciting part of data science and machine learning, but it is definitely the most important. All right, I'll see you at the next section.